Welcome back and good morning. It's only 8. It's not even 8 a.m. Let's try read it again. But I need to close the door. I'm not awake yet. It will be a long hot weekend. It's already 25 degrees and it will be like 30 in few hours. Will be 30 degrees. So I'm thinking to start reading now before the heating get up. But yes, I cannot always pause the reading. No, I need to read this in 2 parts because this is super long. So let's try again.
M60 tank. M60 pattern redirects here. For other uses, see M60, disambiguation. The M60 is an American second-generation main battle tank, MBT. It was officially standardized as the Tank Combat Full-Tracked 105mm gun, M60 in March 1959. Although developed from the M48 pattern, the M60 tank series was never officially christened as a pattern tank. It has been called a product-improved descendant of the pattern tank's design. The design similarities are evident comparing the original version of the M60 and the M48A2. The United States fully committed to the MBT doctrine in 1963, when the Marine Corps retired the last M103 heavy tank battalion. The M60 tank series became America's primary main battle tank during the Cold War, reaching a production total of 15,000 M60s. Hull production ended in 1983, but 5,400 older models were converted to the M60A3 variant ending in 1990. The M60 reached operational capability upon fielding to U.S. Army European units beginning in December 1960. The first combat use of the M60 was by Israel during the 1973 Yom Kippur War, where it saw service under the Magak 6 designation, performing well in combat against comparable tanks such as the T-62. In 1982, the Israelis again used the M60 during the 1982 Lebanon War, equipped with upgrades such as explosive reactive armor to defend against guided missiles that proved very effective at destroying tanks. The M60 also saw use in 1983 during Operation Urgent Fury, supporting U.S. Marines in an amphibious assault on Grenada. M60s delivered to Iran also served in the Iran-Iraq War. The United States' largest deployment of M60s was in the 1991 Gulf War, where the U.S. Marines equipped with M60A1s effectively defeated Iraqi armored forces, including T-72 tanks. The United States retired the M60 from frontline combat after Operation Desert Storm, with the last tanks being retired from National Guard service in 1997. M60 series vehicles continue in frontline service with a number of countries' militaries, though most of these have been highly modified and had their firepower, mobility, and protection upgraded to increase their combat effectiveness on the modern battlefield. The M60 has undergone many updates over its service life. The interior layout, based on the design of the M48, provided ample room for updates and improvements, extending the vehicle's service life for over 4 decades. It was widely used by the US and its Cold War allies, especially those in NATO, and remains in service throughout the world, despite having been superseded by the M1 Abrams in the US military. The tank's hull was the basis for a wide variety of prototype, utility, and support vehicles such as armored recovery vehicles, bridge layers and combat engineering vehicles. As of 2015, Egypt is the largest operator with 1,716 upgraded M60 A3s, Turkey is second with 866 upgraded units in service, and Saudi Arabia is third with over 650 units. Development, edit. Impetus, edit. The United States entered a period of frenzied activity during the crisis atmosphere of the Korean War, when America seemed to lag behind the Soviet Union in terms of tank quality and quantity. Testing and development cycles occurred simultaneously with production to ensure speedy delivery of new tanks. Such rapid production caused problems, but the importance given to rapidly equipping combat units with new tanks precluded detailed testing and evaluation prior to quantity production. The M47 pattern entered production in 1951 and was used by the United States Army and Marine Corps, but ongoing technical and production problems kept it from serving in the Korean War. The M48 pattern tank entered U.S. service in 1952, but its early designs were deemed unsatisfactory by Army Field Forces, AFF. The improvements to the M48 focused on improving the 90mm main gun and fire control systems while simultaneously exploring the development of silica's glass composite armor and autoloader systems. The tank continued further development through 1955 in conjunction with its simultaneous mass production. The course of its development during the mid-1950s was the source of widespread debate among congressional budget oversight committees. The T-95 program, which began in 1955, was intended to supersede the M48, featured a host of innovative and experimental components such as its 90mm smoothbore T-208 cannon rigidly affixed to its turret, experimental X-shaped engine design using a vapor cycle power plant fueled by hydrocarbons, composite armor and infrared rangefinder. The burden of developing them, however, slowed the overall program to a crawl. During the Hungarian Revolution of 1956, a Soviet T-54, a medium tank, was driven onto the grounds of the UK's embassy in Budapest by the Hungarians in November. After a brief examination of this tank's armor by a British military attaché, it was concluded that the 20-pounder, 84mm L/66.7, was apparently incapable of consistently defeating its frontal armor with high explosive anti-tank, heat, or armor-piercing capped, APC, ammunition. Its 100mm gun was a significant advancement over the weapon of the T-44. There were also rumors of an even larger 115mm gun in the works. These events spurred the United Kingdom to begin upgrading existing tanks with a 105mm high-velocity rifled gun in 1958, the Royal Ordnance L7, to keep the Centurion viable against this new Soviet tank design. The United States responded by starting development of the M60 tank in September 1957. This new tank design incorporated many Army Combat Vehicle (ARCOV) Committee improvements to the M48A2, chiefly the use of diesel engines to increase its operational range and the use of a more powerful main gun. Choice of components, edit. M68 105mm main gun, edit. The main gun was chosen after a comparative firing test of 6 different guns carried out on the Aberdeen Proving Ground in 1958. The factors evaluated were accuracy, lethality of a hit, rate of fire and penetration performance. A Jordanian M60 A3 firing its main gun in 2015. An M48 A2C was fit with the 90mm M41 and tested with the new T300E53 heat round. A smoothbore version of the 90mm, the T2089, was mounted on the T95E1 tank and tested the T320E62 armor-piercing discarding sabot, APDS, round. An American variant of the British Royal Ordnance L7 tank gun, under the US designation 105mm T254E1, was mounted on the T95E2 and tested with British APDS ammunition. Finally, two versions of the 120mm gun from the M103 were trialled, the existing M58 model and a lightened variant known as T123E6 which was mounted on the T95E4. The T123E6 was preferred by the Ordnance Department because its ammunition, the same as that for the M58 gun, was already at an advanced state of development. However, the ammunition was in two parts, shell and propellant bag, which required significant time to load. In the M103 this was addressed by adding a second loader, but a medium tank would not have the internal space needed for another crew member and the firing rate would suffer as a result. In testing it demonstrated a maximum rate of 4 rounds per minute versus the T254's 7 RPM. Based on these tests, the 105mm T254E1 was selected, modified to the T254E2 and standardized as the Canon 105mm gun, M68. It used a vertical drop breech block instead of the T254E1's horizontal sliding breech block. Until American-made barrels could be obtained with comparable accuracy, British X-15/L52 barrels were to be used. US-built XM24/L52 barrels, 218.5 in, 5,550 mm, in length, fitted with an eccentric bore evacuator were used for the M60 series starting in June 1959 but retained interchangeability with the British X-15/L52 barrel. All of the US guns and XM24 barrels were produced at the Waterflyet Arsenal, NY and the gun mounts, M116 for the M60 and M140 for the M60 A1/A3, were manufactured at the Rock Island Arsenal, IL. Because the evacuator was positioned lower on the gun's barrel, US M68 guns were fitted with an eccentric bore evacuator instead of a concentric model in order to provide more clearance over the rear deck. The M68E1 gun shares the same firing characteristics as the M68. It featured several design improvements including an updated gun hydraulic configuration, a stabilization upgrade for the gun, a gun elevation kill switch for the loader, improved ballistic drive allowing the accurate firing of long dart penetrators and other component refinements. The gun is capable of using a wide range of ammunition including APDS Tracer, APDS-T, M392 and M728. Armor-piercing fin-stabilized discarding sabot tracer, APDS-T, M735 and M774, APDS depleted uranium, DU, APDS-DU, M833, Heat FS, M456, APDS dummy and target practice rounds, high explosive plastic, HEP, /high explosive squash head, HESH, M393, white phosphorus and canister rounds. Barrels with thermal sleeves were used starting in 1973. Both the original M60 variant as well and the initial configuration of the M60A1 used the M68 gun. Additionally, many M48A3s armed with a 90mm gun that were in service with the Army National Guard, ARNG, were retrofitted with the M68 gun during the mid-1970s and redesignated as the M48A5. This was done to maintain training levels of ARNG units as well as using a commonality in ammunition amongst tanks. M60A1 Rise, reliability improved selected equipment. Passive tanks built after 1977 and all M60A3 tanks were armed with the M60AT1 variant of the gun. It had an improved ballistic drive to allow for accurate firing of the M735 AFS's ammunition. Most M60A1 Rise tanks were retrofitted to this standard by applying the M735 cam update from the M60A1 PIP turret update kit. Armor, edit. Composite armor made with fused silica glass sandwiched between plates of steel were intended to be fitted to the hull. This led to a redesign of the front of the hull into the shape of a flat wedge, instead of the M48's elliptical front, as it simplified the installation of this armor. It was also envisioned that the T-95E6 turret was to be constructed solely with this special armor. The U.S. Army Ordnance Tank Automotive Command, ATAC, and the Carnegie Institute of Technology began development of the armor in November 1952 at Fort Beaver, VA as Project TT2-782/51 using examples of the T-95 tank to conduct the ballistics testing. This composite armor provides protection against heat, HEP/HESH and HE rounds. However, field-repaired panel castings suffered a loss of kinetic energy protection. Limitations in manufacturing capacity and the added cost led to this armor being dropped by November 1958 and all M60 series tanks were protected with conventional steel armor, but the tank retained the capability to employ armor panels. The M60 was the last tank to feature an escape hatch under the hull. The escape hatch was provided for the driver, whose topside hatch could easily be blocked by the main gun. There were two versions of hulls used for the M60 series. The M60 hull had a straight slope and beak compared to the earlier M48's rounded one. The hull bottom had a strong boat-like appearance with a pronounced recess between the upper tracks and external suspension arms and one shock absorber on the first rotor wheel pair. The armor was improved, at 6 inches, 155 millimeters, on the front glacis and mantle of solid rolled homogeneous armor, while it was 4.3 inches, 110 millimeters, on the M48. The first prototype hulls did not have shock absorbers and were briefly named M68 in late 1958 before the Ordnance Department renamed it the M60 in March 1959. This hull version was used only on the original M60 variant and early M728 combat engineer vehicles, CEVs, and M60 armored vehicle launched bridges, AVLBs. This hull model was in production from 1959 to 1962. The M60A1 hull has basically the same visual characteristics. The noticeable difference was the addition of a second shock absorber at the second rotor wheel pair and was also accompanied by a slight relocation of the first return roller. These modifications were needed due to the increased weight of the M60A1 turret as well as the additional hull armor. This hull model was used on the M60A1, M60A2 and M60A3 models of the M60 series as well as the M728A1 CEV and M60A1 AVLB. It was in production from 1962 to 1983. The M60 series went through a progressive turret design scheme during its production life with 4 different turrets being manufactured for the M60 series. The T-95E5 turret used on the M60 was hemispherically shaped and bore a strong resemblance to the M48 pattern. The M60A1 was the first version to employ the newly designed T95E7 turret with a redesigned bustle, increasing the number of rounds for the main gun to 63. The M60A2 featured a specially designed turret for the M162 gun forward/missile launcher that greatly reduced the frontal arc in comparison to the M60A1's T95E7 turret. The M60A3's turret was similar to the A1's but with increased armor protection for the frontal arc and mantlet in an effort to provide additional protection of the turret's hydraulics system. M19 Commander's Cupola, edit. A redesigned full-vision cupola was envisioned for the commander's station. It had 7 tiltable vision blocks arranged to give the commander a 360-degree field of view with overlapping vision between adjacent vision blocks. The front vision block could be replaced with a dual-power M34 750 binocular day sight or an M19E1 infrared IR periscope. A special feature was that the cupola body could be raised up to 3.5 in, 89 mm, providing the commander a direct field of vision while remaining under armor protection. Access was through a hatch cover on the roof, and a .50 caliber M2 heavy barrel HB machine gun was pedestal mounted on the forward part of the cupola. It could be aimed and fired with the cupola closed. Also there was an 11 in, 280 mm, long hydraulically operated port on the left side, allowing spent cartridge cases to be ejected. After creating a full-sized mock-up of this design using the T95E6 turret, it was dropped in favor of a design based on the M1 cupola of the M48A2's turret. This T9 cupola provided the commander with more headroom than the T6 cupola of the T95 tank, carrying a new short receiver M85 forward/T175.50 caliber machine gun, and it was standardized as the cupola tank commander's caliber .50 machine gun, M19. The first M19 cupola, a modified T9, was ready on the 27th of October, 1958. It has an M28C sight for the machine gun in the forward part of the cupola and 8 vision blocks. The front vision block can be replaced by a M19E1 infrared periscope or an M36E1 passive periscope for night observation. Initial production of the cupola was problematic. The first 300 M60s produced were armed with a .50 cal M2 HB machine gun in a pedestal mount welded to the left side of the commander's cupola owing to production problems with the new M85 machine gun. Of these tanks, the first 45 manufactured were made without the cupola itself, also due to production problems. All of these early M60s eventually had the M19 cupola and M85 machine gun installed. Compared to a conventional pintle mount, the remote-controlled M85 machine gun was relatively ineffective in the anti-aircraft role for which it was designed. Removing the cupola lowered the vehicle's relatively high silhouette. The cupola's hatch also opened toward the rear of the vehicle and was dangerous to close if under small arms fire owing to a lock-open mechanism that required the user to apply leverage to unlock it prior to closing. The commander was able to observe the battlefield using the X4 binocular M34D daylight vision block or the M19E1 IR or M36 passive periscopes while remaining under armor protection with a 360-degree traverse independent of the turret, was stabilized in azimuth and elevation and carried 600 rounds of ammunition. All M60s in U.S. service retained the M19 cupola until the tank was phased out of service. The few M60A3s in Army service as training vehicles had their commander's cupola removed as it was deemed unnecessary for training and to better mimic the profile of Soviet tanks. Some M48A5s were retrofitted with the M19 cupola to maintain training levels of ARNG units. Main battle tank designation, edit. The concept of the medium tank gradually evolved into the main battle tank, MBT, in the 1960s. The MBT was to combine the firepower and protection sufficient for the assault role with the mobility to perform as a medium tank. The MBT thus took on the role the British had once called the universal tank in the late 1950s, exemplified by the British Centurion, filling almost all battlefield roles. Typical MBTs were as well armed as any other vehicle on the battlefield, highly mobile, and well armored. Yet they were cheap enough to be built in large numbers. The first generation consists of the medium tanks designed and produced directly after World War II that were later redefined as main battle tanks. These were exemplified by the M47 and M48 patterns armed with a 90mm main gun already in widespread US service. The original variant of the M60 series also fulfilled the definition of a late first-generation MBT, sometimes being referred to as an intermediate second-generation design. The Soviet T-54 and T-55 as well as the original configuration of the T-62 tank designs are also regarded as first-generation MBTs. The second generation had enhanced night fighting capabilities and in most cases nuclear, biological and chemical, NBC, protection. Most Western tanks of this generation were armed with the 105mm Royal Ordnance L7 tank gun or derivatives of it. Notable are the British Chieftain and German Leopard 1. The United States fully committed to the MBT doctrine in 1963 when the Marine Corps deactivated its last M103 heavy tank battalion. The first American nomenclature-designated second-generation MBT was the M60, a one version of the M60 series. The term MBT is used in strategic doctrine and the composition of force as determined by the United States Army. The M60 series tanks fulfilled the MBT role on a strategic and tactical level. It was never referred to as such in any official training or technical manuals. The first Soviet second-generation main battle tank designs were the T-64 and T-72. Production versions, edit. XM60 development, edit. By May 1957, it became clear that the T-95 medium tank would not have a significant advantage over the M48A2. The X-shaped motor and electro-optical rangefinder were both discarded due to performance, and the accuracy of the smoothbore gun and its high-velocity APDS ammunition continued to be unsatisfactory. The T-95E6 turret was to be made with the advanced silicas armor but was never constructed. All this led to the closure of the T-95 project on the 7th of July, 1960. But the T-95E7 turret design using conventional hardened steel armor was carried forward, becoming the M60A1S turret. The course of the M48 pattern's tank production was the source of widespread congressional debate. The Bureau of the Budget believed that the Army was not progressing with sufficient speed in its tank modernization program and recommended the immediate replacement of the M48A2. Correctly predicting that Congress would not approve the procurement of the M48A2 after the fiscal year 1959, the Deputy Chief of Staff, Logistics, XLOG, proposed a tank based on the M48A2 featuring improved firepower and the AVDS 1790 engine. Since the main gun had not yet been specified, 4 XM60 weapons systems were submitted in September 1957. The first concept was armed with the 120mm gun T123E6 in the long-nosed T95E6 turret. This was the design preferred by the Ordnance Department. It was fitted with a mock-up of the new designed full-vision commander's cupola. A full-sized prototype of this turret was constructed before this concept was dropped, mainly due to its slow rate of fire. The second carried the 105mm rifle T-2541 main gun in the T-95E5 type turret and the T-9 cupola style of the M48A2. The T-254 guns used British X-15 forward/L-52 barrels with a concentric bore evacuator on the barrel. The Army Ordnance Technical Committee chose this design for production in